Hey, welcome to part three. So the other part of the water source resources that we have is wetlands. I think in our chapter in the biomes, we actually learned about wetlands and how valuable they are and types of agriculture. And in the United States, most of it has been actually, in this it says, oops, more than half of it has actually been converted for agricultural use. Now, this part of it that you see is something that I've added. Very interestingly, I found that Brooklyn and San Francisco were at one point of time wetlands. Are they wetlands now? No. San Francisco and Brooklyn, I don't know about Brooklyn, but San Francisco might actually be very densely populated. In terms of cities, it might be one of the more densely populated cities. So there are a ton of different federal agencies that have primary responsibility for protecting the wetlands. Everything from Department of Defense to EPA to Department of the Interior, the Army Corps of Engineers, U.S. Wildlife and Fish Services. What kind of water is discharged into the wetlands, that part is controlled by the Clean Water Protection Act, which is right here. This one controls the discharge. This is going to be a very important point. You can definitely expect to see something that distinguishes between who controls the land itself and who controls the discharge in terms of questions on your AP environmental science test. So the discharge, what kind of water is discharged into wetlands. Remember, wetlands are not isolated wetlands, and I'll get to that in a second, are not isolated. They kind of are connected to other water sources. They have to be connected to a water source to form a wetland. There has to be some kind of water source connected to it. Wetlands are just a place where you have thick loam soil. Yes, the soil chapter is coming up very soon. So while the protection of the wetlands as a resource is done by all these other agencies, everything from here, the discharge, what type of water is discharged into the wetlands, is done by the Clean Water Protection Act. I think 1972, but I'd look it up. Now, all these agencies definitely are protecting wetlands, and some of you who are in my class live on wetlands. So technically your backyard is a wetland, but your house is not. That is, your house was not built on a solitary rock that was sitting in the middle of wetlands. There is a way around which, there's a way to get around this wetland quandary and actually do development on it. For example, one of the things, if you want to build an industry, a housing complex, you have to first do an environmental impact report and say that getting rid of this particular wetland will not impact the environment, which is a nice way of saying bullshit. And you also would have to prove that the wetland is not connected to any other wetlands, which is another way of saying bullshit. So once you've done this, then you also have to produce, like, talk about how there's going to be an economic benefit by doing this, and you're really not harming the environment. A certain amount of the wetland would be under protection. Just blah, 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 have to turn in a bunch of paperwork to the EPA, to your state government, and then you can actually get permission to build on wetlands. So by building houses in the Stamford area, the protection of this wetland, they kind of moved it from the city to whoever is living in that house. So you by yourself may not be able to do anything in your backyard because you don't have the resources for it, just because you're not a multinational corporation. If you were a multinational corporation, there are many, many ways to get around this wetland. Half of the wetlands was not used for agriculture and industry and housing, just because they were protected. That's not how it worked. So there's always ways around any laws in the United States. Very simply put, when money talks, bullshit walks. A small amount of water is also contained in in the atmosphere. There's water vapor in the atmosphere, but there's a rapid turnover rate. Remember, water vapor that's in the atmosphere is, it's in the process of evaporating, becoming clouds, coming back down, all of that stuff. So water availability and its uses, as far as potable water, a lot of renewable sources are rain. When you have rain, you have runoff, and this runoff again infiltrates into your aquifers, and then it's stored there, and then human beings can use it. A lot of it is diverted into streams and rivers and all of these things, which eventually lands up having seasonal floods. But seasonal floods are actually they're not a bad thing. In the past, I think we've talked about this. Why is it that we need to take certain kind of vitamins? I think we've talked about seasonal floods also bring in silt. This silt, when deposited on land, is very fertile soil. So it's not always a bad thing to have a flood. But nowadays, when you have new housing complexes that are developed, or new housing what do you call those, colonies developed, it is mandatory for them to put in storm drains and catchment basins and stuff like that, and the water that's collected in the catchment basin is, again, it's a lot of it evaporates, so it's back into the cycle. Some of it is also is purified and then used as reclamation water. We will talk about reclamation water later on, and it's used for agriculture. It's used for keeping your neighborhood lawns green, especially if you have community property, community lawns and community parks and stuff like that within a housing development. The water from those storm drains are the ones that's used. Now, one of the things we have talked about this about water scarcity, and how eventually water scarcity, especially in agrarian societies, have led to later on civil war, not civil rights, civil war and stuff like that. Interestingly, I found something very interesting was that in the United States, we use about 4 times more water than countries in South America. However, we pay about 25% less for the same water as they do there, because water stress not only puts renewable waters, not only like reduces the amount of water that's available to people, it also increases the cost of water. Water is not free. The distribution of water is not free. The storage of water is not free. The cleaning of water is not free. In every part of the world, you have to pay for it. You either pay for it because it's clean and distributed to your house, or you pay for it in terms of healthcare cost. Water is not free. In a country like the United States, we actually pay very, very little for water. So while the bigger problems with water scarcity is basically droughts, there are more subtle problems. For example, when you have a shortage of rain, when the price of water goes up, people who can't afford that water are actually now drinking water from contaminated sources, which increases the healthcare cost. So it's not always clear cut as, okay, there's no water, so there is a drought. Sometimes there could be just a small decrease in the annual rainfall, or the can lead to like really awful effects, not for people who can afford to buy water, can afford to pay for the higher cost of water, but for people who can't afford to pay for higher cost of water. This is an interesting chart. It's pretty self-explanatory. Yeah, this is interesting. Ice and snow constitute 87.2% of the fresh water. I was in Stanford a couple of days back, and they have this huge big reservoir, and I was talking to someone there in um, something to do with housing development. So I was talking to someone there, and they were talking about how because of the fact that they don't seem to be having the winter that they should have, the water levels in the reservoir has really gone down, and that's going to actually, according to the guy who works, according to some of the people who work in the housing development there, they were talking about how the cost of water in Stanford is really going to go up because the reservoir has gone down. The amount of water in the reservoir has considerably gone down because it hasn't been replenished with the usual snow that they get. Now that, so yay, we're not the only one in California suffering. You in Connecticut can suffer. Oops. This is just basically data. The human population, we have talked about this in the past. Once we are fast hitting our carrying capacity and are not showing any means of slowing down anytime soon. Again, places that have larger population growths tend to be more agrarian societies, tend to be societies that are more dependent on renewable sources of water. So when there is a problem with that renewable source of water, those societies are the ones that are really going to be impacted. And those are the areas. If they're agrarian societies, those are the societies that are seeing a larger increase in population. So wonderfully, Canada draws less than 1% of its renewable supply of water every year. That's because they get more snow than they know what to do with. Now, countries like Israel, Libya, and Yemen have almost depleted their renewable sources. Again, remember, Israel is in the middle of a desert, and they have artificially created a landscape that actually makes them agriculturally sustainable. They are self-sufficient when it comes to agriculture, and that is an artificially created situation. That means they tend to use up all their renewable water sources. The United States uses about 20% of its renewable water every year. So, as you can see, the greatest culprit here is agriculture. I don't know if you can call it culprit. We all need food. Industrial is obviously not as much. And domestic. Now, this is the area that all of you can make small contribution. All of you and me can make small contributions, and we can reduce the amount of the consumption part of it, out in this area. We could so when I'm talking about consumption, I'm talking about your consumption, your particular consumption. So most of about 3,200 metric cubic meters of water is withdrawn what's drawn is used from the water bodies. This is not taking into consideration just rainfall and stuff like that. Most of it is evaporated, is loss of due to evaporation, contamination, or absorption. Think about it. When you look at agricultural resources, a lot of water is wasted because of runoff, and that water is not actually clean water because it is combined with all sorts of fertilizers and soil and silt and all that stuff. It's not clean water. Evaporation is not really a total loss because you tend to get it back. Now, in a place like California, evaporation can actually be a loss because of the wind, because of the Santa Ana winds, or evaporation gives Seattle rain. And this has actually been a lot in the news. Agriculture has been a lot in the news because of California. California grows a lot of cash crops. I'm sure everybody enjoyed strawberries today. And those are very water intense crops, and they come from the Central Valley of California, where we have a water crisis. So we tend to draw water out of the ground. So most of it is groundwater that's being used. So agriculture, again, I'm going to go over the next slide. I'm going to talk a lot more about agriculture and the Aral Sea and stuff like that. I'm running out of time, so I'm going to push this off to the next slide.